Welcome back to the 14th part of Debugging at Scale, where we eliminate the bugs. The process of elimination is one of the oldest and most powerful debugging techniques. The core principle is simple. Slowly remove parts that aren't the cause of the problem until the problem reveals itself. We can accomplish this by commenting out code or by using debugger tricks such as force return to disable a specific code flow. We can also use external tools when experiencing a front-end issue. We often try to reproduce the issue in curl Postman to verify whether the issue is related to the front-end code. By eliminating large swaths of code from our bug search grid, we can find the issue faster. This is an especially powerful tool because it usually helps us narrow down on the bug and root cause, not just the symptom. Unit tests are a great way to debug, as they can often isolate the problem to its core elements. We'll discuss unit testing more in depth later on. The biggest benefit of debugging, though, through a unit test is that we can leverage mocking frameworks such as Mockito. These frameworks let us remove large swaths of code and narrow the problem space considerably. The benefit of avoiding regression and simplifying our test cases are a bonus. Notice that there are various best practices that cover the right amount of mocking per test. When building a test case to debug a specific issue, these practices don't apply as much. Mock everything you need to reduce the problem to its bare essentials. The process of elimination works great when we have a problem that's easily reproducible. Flaky issues or issues that turn out to be flaky as we eliminate code are a major problem. The solution for this is to only work on negatives and never on positives when performing elimination. This can be confusing, but it's an important rule. If you eliminate a block and the problem doesn't reproduce, this doesn't mean that the problem is related to that block. It could be flakiness. However, if you eliminate a block and the problem reproduces, then this block is probably not at fault. So only rely on cases where the problem reproduces. I would also run checks repeatedly if you suspect flakiness to verify that a problem doesn't occur on multiple runs. We were chasing a complex threading issue and were commenting out code left and right. We made the incorrect assumption that a specific piece of code was the cause, since when we commented it out, the problem stopped happening. We spent a lot of time looking at that code instead of continuing the investigation. That code just impacted performance and exposed a race condition located in a different location altogether. We used tongs to grab hold of an item on both sides. The same concept can apply to almost any piece of software, as pretty much all software has two or more directions of input and output. Let's give you some examples. For a typical enterprise web app, one side is the web UI, the other side is the database. For an operating system kernel, one side is user space app, the other side is the computer hardware. For a game, one side is the joystick and screen API, the other is the game database. Let's discuss the concrete example of an enterprise web app. The tongs start by mocking the web tier with curl or Postman. This eliminates front-end related issues. The other side of the tong motion is replacing the database with mock data. If the issue can be reproduced, we can further squeeze the tongs by invoking the presentation tier method directly in the test case. We can then eliminate the database entirely from the equation by mocking it. Next, we can invoke the business method directly eliminating the presentation tier aspect. We can mock its dependencies, which means we narrow down on a specific method that's at fault, while eliminating the rest of the application. A common mistake is to move only one prong of the tongs, or not position the other tongue. If you don't position the tongs, your investigation might impact the other side and you wouldn't know what's going on. You don't have to move both tongs for all cases, but if you're stuck, then you can always flip the direction of motion and investigate from the other side, then flip back when convenient. We were debugging a performance issue in a server deployment. I replaced the web calls with a curl request, which moved the tongs forward towards the problematic area. On the DB side, I placed heavy DB logging to see the output as I reproduced bad SQL via curl. By leveraging both sides and moving deeper into the DB layer from both sides, I was able to locate a bug in the object relational mapping layer. In the next video, we'll talk about the process of resolution. The bureaucracy that underlies debugging is sometimes a powerful tool. Without it, we would face resurgence of bugs that we already solved. If you have any questions, please use the Slack channel to ask them. Thank you.